In this video, I'm going to walk you through lesson 1 of the P.1 unit from OpenSciEd. It's all about energy flow from Earth systems. Now, before we do that, I want to point out there's a slideshow below linked in the window, and that is what I'm using to go through each of the lessons. Go ahead and open it up and click along and follow along as I open up different hyperlinks to resources, key slides, handouts, things that you can push pause on the video and look a little bit deeper at. But let's go ahead and get started. Now, before we go into lesson 1, I'm going to talk about the slide 2, which has a flow chart to show the flow of the unit. Now you'll see that there are 2 lesson sets. The first lesson set right here answers the question, how does electricity transfer through systems to power communities, and what causes instability in these systems? This is anchored with the phenomenon of the Texas blackout in 2021, and we learn all about electric circuits and sources of energy and everything to do with that power outage, to then try to design a solution. So the second lesson set is actually an engineering challenge, and we develop some engineering ideas along the way, but they all get used to design an electric grid for their community that is reliable. And so we learn about criteria and constraints and trade-offs. And so it's a kind of a hybrid unit where we have an anchoring phenomenon and an engineering design challenge. Now, over here on the left, you can see that there are categories that I like to provide for teachers to create a driving question board. Often teachers are nervous that the questions students ask will not actually connect to the lessons that are in the storyline. And I used to be nervous about that too. And until I ran the anchoring phenomenon routine many times, and every single time the questions that people ask were in the categories related to the storyline. And that's partly because that's the way these units were designed or developed. So in the teacher edition, you're going to see a lot of guidance on how to develop an initial consensus model and create these subsystems for energy source, transport, and destination. Now, in the teacher edition, there is a sample driving question board where they put the sticky notes right onto the initial consensus model. So you'll line them up with these 3 subsystems that are already identified. Now, I personally don't like that strategy because if I want to reference that consensus model, it's covered with sticky notes. I also like to combine driving question boards from different classes together. So it makes it a little bit harder when you have different initial models. Anyways, you'll figure out what works best for you. But if you do them separate, here's some other categories you might be able to use. I will show you an example of this when we get into lesson 1. Now, let me move my face here. There are some summative assessment opportunities. The first one being in lesson 6, it's a transfer task, which means we take all of the science ideas developed in lessons 1 through 6, basically, and we take a transfer task at the end where they apply it into a new context. The context in this one will be about motors. Then we move into lessons 7 and 8, and there is actually an exit ticket at the end of lesson 8 that is considered a summative assessment. You can even beef it up with a few more questions if you want. Then we go back into lesson set 2, and there is an exit ticket in lesson 10, but it's considered formative to see if students are ready for the culminating project. I think there's an opportunity here to really turn that into a summative assessment if you need another grade for your grade book. So then the culminating project is a summative assessment. It's the design project. And so can they use the criteria and constraints and their understanding of energy transfer to design a grid for their community? And then the ending transfer task, also in lesson 11, is all about a solar power plant. It's called Sand and Mirrors. And so it's using all of that information developed so far into that final transfer task. Okay, let's move into lesson set 1. It all is going to be about how does electricity transfer through systems to power communities and what causes instability in these systems. So it's introduced in lesson 1 by the anchoring phenomenon, which is the 2021 blackout in Texas. You will see that students are going to jigsaw 6 different articles. And so you put them into groups. Here are links to all the articles. They're going to take notes, stop and jot, take notes, and then they're going to respond to this slide right here, which is a prompt. They're going to read one article, keep track of any new words, and what might be important. And when they're done, they're going to relate it to themselves. So can you relate to the story? Have you ever lost power? Has this happened to you? That's really important to build relevance to the anchoring event. If you didn't live in Texas, maybe you had a similar situation. All right, we're then going to share our learnings and discuss some questions that we are asking about those articles. And so each person will have 2 minutes in their small group to share about their article. And when they're finished, the group will talk about these 5 questions together. We look at a Texas blackout map and write down some noticing and wonderings that it definitely does not happen all throughout the state, that some areas are more affected than others, and some have power out for a much longer time than others. And so this leads to some more curiosities. We write down what we notice and wonder. We create a public record of this. Here's an example from a professional learning event. Some things we noticed and wondered. Students will have much more than this, but you can see how we document this as a public record, and students share what they are thinking. And then we brainstorm some related phenomenon. And here is the slide that will help you prompt to do this. They already stopped and jotted, so we haven't shared that yet. We now can share it now. That kind of was a scaffold to get some ideas out here. And then we create a chart of sample related phenomenon. So this was again from a professional learning event. We live in Southern California, so we have fires that often turn out or turn off our electrical grid. But anyways, construction, circuit breakers. So you get a lot of personal experiences from students when you create that public record. We then develop initial models and we answer some initial questions. Now, here is the handout that is given to students, and it has a lot of scaffolded prompts. You can see that they are going to be asked to think of any 2 buildings and how are these buildings connected in a community, and what structures transfer energy to them. Anyways, a lot of prompting questions that's going to help you get to that consensus model that I'll show in a moment. Before we do the consensus model, we're going to have students share models with one another using a gallery walk. And this is really to help us, and here's the slide that helps prompt this, to help us look for things that are similar and different. And this is going to help you build your consensus model. If you find things that are similar between models, this helps you then understand that you're not alone in your thinking, and it helps build confidence for students to share it. If something's different, it also shows us that we're not in agreement and we have some things to figure out. So we're going to look for similarities and differences and then come back together and share those out and build a consensus model. Now, the way we do this is that students provide ideas. I usually ask one student at a time to give me one thing for the model, and I draw it on the model. And I say, okay, how should I draw this? Should it look like this? Would this be a windmill? And if anybody disagrees or is uncertain, I will ask for that. Is anyone unsure if windmills are used? If anyone raises their hand, we put a question mark. The idea is we want a lot of question marks on our initial consensus model because this helps us ask questions that we can then answer down the road. Here is, there is guidance in the teacher edition to kind of develop that term systems in the context of this phenomenon. We use 2 to 4 labels to then identify those systems, which would be the system of energy production or energy source, where that energy transfer is happening, and where the destination is. And so remember that systems can have multiple subsystems. And here is a sample. This is the one I made in a professional learning event. It does not look as neat. That is perfectly fine. It's okay if your consensus model does not look like the one in the teacher edition. At first, I was very careful to try and make it look the same, but you're going to write down what students are offering, and that doesn't always go in the same order as what you see in the teacher edition. But you can see I do have the source here. We have SoCal Edison, power plant. These are ideas that the students gave, actually teachers in participating as students. Here is transport. We also labeled it distribution. And then users, destination. So I'm using the language of the students. Again, it doesn't match perfectly the teacher edition, but I'm valuing student ideas. So then we're going to actually complete our first progress tracker in the unit. Now, a progress tracker is where students write down ideas that are helping them show their learning over time, show how their thinking is changing, but also helps them metacognitively process their learning and write it down in pictures and words. I will provide a link below to a template progress tracker and also an answer key in the deep dive storyline. This unit actually has two types of progress trackers. This one would be considered all about the science ideas. And so they're going to put down what they figured out. How did we figure out? I will provide a template. Some people use a handout. Some people save some pages in their notebook to have all the progress trackers together in the notebook. So they save like 10 pages aside when they set up notebooks. Some people hand out a Google Doc or a handout. I have a template below for you that I will link. But here is the unit answer key for the science ideas that are figured out. And so it's not normal that we do this in a lesson one, but this unit does have a lot of vocab developed in lesson one. You can see lesson two, we're going to be doing some short circuits. And so I've just provided the answer key for you, but there will be an engineering tracker too. So one thing you need to decide is how you're going to track engineering ideas and how you're going to track science ideas, because they're going to use all of these to develop their solution in the end. We then brainstorm some ideas for investigations or more data that we might need. This is the prompting slide. We're thinking about what additional data or information we would need. You might record some here. Notice that you're going to come back and do this again after we do the driving question board. Here's a sample from the professional learning. This are some ideas for investigations. We should model energy transfer, which we totally do. You will find that student ideas often appear in the unit. It doesn't mean you need to do these, but they can see how scientists come up with investigation ideas and how that helps figure out an anchoring phenomenon or help design a solution. So between these two investigation idea moments, we're going to ask questions, and here's the slide that prompts that. Students are going to put one sticky note per question. Now, I will say if you have a very large class, that can be a lot of sticky notes. So I'm going to give you a quick idea of how to do this by putting students into small groups and having each group, first they share their questions with the small group, and then each group decides on their top 3 questions, and they write those down on sticky notes. Now, here's an example driving question board from the teacher edition. You can see they put the questions right on the consensus model. And so a lot of questions about energy sources, some about destinations, but I find that this really covers your consensus model. I like to do it separate. Here is my sample driving question board. You can see very small group that we had, but these were our categories. So remember I mentioned those categories at the start of this video. These are going to be investigated the loss of power, how the circuit grids work in the beginning of the unit. Transport, this is more the middle of the unit, as well as sources. Prevention and efficiency, this is always going to come up because we don't want this to happen in our community. This is lesson set 2, all about designing a new plan. Now, I will say that creating a driving question board can be a little bit difficult. So one thing I do is I ask for the first question to be shared out, and then I go collect that question, I stick it on my hand, and I say, does anyone else have a question related to this? So let's say someone said, where does our energy come from? And so I'll ask, does anybody else have a question related to where energy comes from? And I go around and I collect all the sticky notes and I place them all on my hand. And then I go up to the board and I place them on the driving question board and I label it energy source, because I've already developed that term on the consensus model. Now, what I'm doing here is I'm creating the categories, because I'm going to control what we're looking at on that driving question board throughout the unit. That category is used for navigation. You say, what categories have we answered? What haven't we answered? Where should we go next? So those categories are key for navigation. So I like to control what those categories are going to be. Now, all of their questions were about energy source. I'm just naming it. If your students are good at doing this, more power to you. Let them develop the categories. But that's a pretty heavy lift if you're new to creating driving question boards. So once I've asked all the questions about energy sources, or I've collected them all, I say, okay, let's start a new category. Who has the next question? I have them read their question. I collect their sticky note. Okay, does anyone else have a question about what we can do about this? And I collect them all and I make my new category about what we can do about this. So hopefully that helps understand how to make a driving question board. And we're going to brainstorm some ideas for investigations. You can even get the categories and divide them up among groups and say, I'd like this group to come up with ideas and investigations about energy sources. I'd like this group to figure out ideas about how we can make a new design or a plan for our community. So you can use the categories to divide up the who's coming up with ideas for investigations, the topics for investigations, which kind of increases the variety of ideas, but not necessary, just an idea. We're going to then set up some notebooks and some personal glossaries. Now, notebooks are used very differently from teacher to teacher. Some people use 3-ring binders because they use a lot of handouts. It's easy to grade things, take them home, and then hand them back and put them in a 3-ring binder. Some people use composition notebooks. They might not grade as much. And so they're just kind of documenting the process or, to get to the transfer task. Some people use handouts and create packets per lesson. It's up to you, whatever works. I would say use the same method per unit, but don't stick with one method if you're not happy with it. Test out a few methods, see what notebook system works best for your class and your setup. And then we consider, where can we see electricity around us or the electric grid around us? And so students will go home and go around their school and their community and take some pictures, and you'll collect those pictures of where they're seeing evidence of the electrical grid or how energy is being transferred or delivered to destination. So that's it for lesson 1. Pretty big lesson, but it really gets kids interested in what's happening in the electric grid around us. And can this happen to us? What happened in Texas? Can it happen in our community? All right, hope this helps.